Sorry for the interruption. Yeah. Okay, so we were talking about the this circuit as a down counter. Okay, so this was 0, this was 1, so this was 1, here 1, this was 0, this was 0. Okay, okay. So let's talk about the flip flop A. Okay, so this output of this flip flop A is here A. So no matter what is the input of the AND gate, whatever the value of A, the another input is 0. So the output of this AND gate will always be 0. Okay, and in the flip flop, AND gate 3, so one of the input is A complement, another input is 1. So the output will be A complement here. Okay, so since 0 and A bar, okay, so the 0 and A bar, their OR operation gives us A bar. Okay, similarly here, one of the input to this AND gate 2 is 0. Okay, so if any of the input of the AND gate is 0, the output is 0. Okay, and here this input is for the AND gate 4. One of the input is 1, another input is A complement, another input is B complement. So the output will be A complement B complement into 1, which is same as A complement B complement. Okay, so this is the output of this AND gate 4. Okay, since AND gate 4 and AND gate 2 are getting ORed, so 0 plus A complement B complement, the output is A complement plus B complement. Okay, so this is A complement and B complement. So this is A complement and B complement. Okay, so now first of all, before beginning, you know what are the different inputs at each state. ओके, तो कहां पर क्या क्या इनपुट है, किस फ्लिप फ्लॉप बी का क्या इनपुट है. द इनपुट टू द फ्लिप फ्लॉप बी इज ए कॉम्प्लीमेंट. द इनपुट टू द फ्लिप फ्लॉप सी इज ए कॉम्प्लीमेंट इनटू बी कॉम्प्लीमेंट, and the input to the A flip flop is 1 1 as always. Okay, now since we are talking about the down counter, so we have to presume a initial high state. Okay, so initially let's assume that the counter was in a high state. Let's say the counter state was 1 0. I'm taking a random state. Okay, 1 0 1. Okay, we can take it 1 0 0 as well. Okay, so initially we have to assume some higher state because now we want to count the down. Since this is only 3 bits, so it cannot count more than triple 1 up count. Okay, so if this is the state, so what are the different states? Let's check it. Okay, so the input to the flip flop B will be how much? If this is A, okay, so A is 1, so A bar will be 0. So the input to the flip flop B will be 0. Okay, in this state I am talking, and the input to the flip flop C, what will be the input to this? A complement will be 0 and B complement will be 1, and the product of the two will be 0. So this is 0. Okay, so this is the initial state. Okay, so अब क्या होगा? Now the clock comes. Okay, so since the now the clock comes, so what will happen? A is going to toggle. Okay, so this will A change from high to low. So this is a change of A. Sorry, A changes from high to low. Then what is the input to the B? The input to B is 0. So as the clock comes, the state of B is not going to change. So this will remain same. What is the input to C? Input to C is 0. So the state of C is not going to change. So this will remain same as 1. Okay. So now you can see it was initially 5 or 101. Now it changed to 4100. Okay. Then we look for the next clock. Okay. So let's calculate the input to the other flip flop as well again. Okay. So what will be the inputs to the flip flops? Okay. So A bar will be how much? A is 0. So A bar will be 1. Okay. So what will be the input to C? A is 0 and B is 0. So A complement will be 1. B complement will be 1. So the input to this is 1. Okay. So now input to flip flop C is 1. Input to flip flop B is 1. Okay. So now what will happen? All three will toggle. Okay. A में भी 1 1 है, B में भी 1 1 है, C में भी 1 1 है. So all three will toggle. Okay. So as soon as the clock comes, what will happen? A was 0, this will change to 1. B was 0, this will change to 1. C was 0, this will change to 0. C was 1, so this will change to 0. And you can see that it is counting down now. Okay. Again, in this state, we check the what is the input to the flip flops. Okay. So what since now A is 1, so the A complement will be 0. So the A complement will be 0. So A complement here is 0 in the clock C as well. A complement is 0 and B complement is also 0. So the state to this is 0. Okay, 0 into 0 will give us 0. So what will happen in the next clock? So A is having 1 1, B is having 0 and C is having 0. So the state of C will not change, state of B will not change, only the state of A will change. So the state of C is 0, state of B is 1, so the state of A is going to change is 0. Again, after this, again we evaluate the inputs to the flip flops. Okay, so A is 1, so A complement is what? A complement here is 0. Sorry, A is 0, so A complement will be 1. Okay, so B is 1 and A is 0. So their product complement product will be 0. So C will not change. Okay. So what who will change? A will change and B will change, but the C will not change. So C will remain same. A will change from 0 to 1. B will change from 1 to 0. Then again we evaluate the inputs to the flip flops. Okay. Then what will happen? Then what will happen? A is 1. So A complement will be 0. Okay. So B is 0 and A is 1. Their complement product will be 0. Okay. So C will not change, B will not change and A will change. So this will change, this will change. And these two are unchanged, only the A will change. Now you can see from here to here it is counting down. So it is acting as a down counter. Okay. So whether it will act as up count or it will as the down counter is decided by this up down counter input. Okay, if it is 1, so this will count as up. If this is 0, this will count as down. This will work as down counter. Okay. Are you having class after this? Are you having class after this?
Sir.
Okay, then okay. Then I have to stop it here. Okay. I hope you have got the idea of this